Space Tech Expo 2019. I'm very pleased to be joined now from the NASA Marshall Space Flight Center, Dr. Raymond Corky Clinton. Welcome.
Thank you very much. Glad to be here.
You're taking part in some sessions this year, which is fantastic. I know you're going to be talking about things like this. I want to get your insight now. And what do you think are the most exciting developments regarding additive manufacturing for space systems at the moment?
Well, my personal favorite is in-space manufacturing. That's something that we started at Marshall with the vision almost 20 years ago, with the vision of making parts on space station. And over the years, through several tries, I think we finally now have the traction and the rationale to move that forward, and we are in a great way. We have a number of thrust areas that I'll be talking about shortly this afternoon that focus on the needs for deep space exploration and how in-space manufacturing can help address those needs for NASA's future missions.
And what have some of those challenges been then? You say this has been something that's been 2 decades in the making. What are the challenges of manufacturing and engineering for space components?
Well, in the beginning, it wasn't time. We were ahead of our time. And we tried the second time, the agency changed direction and focused more on completing space station, and a lot of the in-space work that we were working on at that point in time was really moved to the back burner to focus on the mission that the President had given the agency. Now we are looking more closely, and exploration missions are on our horizon, and we're looking at those challenges that are presented by deep space exploration. One of those is, of course, the maintenance logistics model that we're currently using. You know, the one for space station simply won't work for deep space exploration missions. You don't get resupply missions, you can't fix and fly your parts, but you do need to have adequate spare parts on space station or on the deep space exploration mission so that you can keep the astronauts safe. And we believe that in-space manufacturing has the capability to address a number of those issues, particularly reuse of materials and recycling of materials. There are a number of packaging materials that are on space station today. We're looking at converting those packaging materials into feedstock that can be used to produce things, simple items like spoons. You're not going to carry 1,000 spoons to Mars, but if you can print a spoon every day or every other day, look at the logistics you save. And there are many other applications of this that we're looking into. Printed electronics, metallic printing, health and medical. That's another surprisingly large source of waste materials on space station. So again, we're taking a look at converting those and being able to reprint those items and not have to carry them all the way with you on deep space exploration.
You've got such a wealth of experience that's worked over those 2 decades, and I just want now to look to the future. Where do you think we'll be in the next decade?
In the next decade, I've used this term before to describe our vision for in-space manufacturing, and that is, we hope the technology will be institutionalized, where if something is needed on space station or in the future on Gateway, when we're looking 10 years out, the astronauts won't call home. They'll simply go make what they need, and it will be a normal part. It will be a standard operating procedure that if they need a piece that we can actually manufacture, they'll just go and make it. Now, they might call down to the ground and say, hey, send up the build file for this particular piece of hardware, but they get it. They get it when they need it, and that's our goal.